So black bodies and all of this. So I guess that's what happens, you have incident wavelength coming in, oscillating electrons. You have induced EMFs that are oscillating the electrons. You can have reflection, you can have refraction because of the induced EMFs, or you can have this energy propagating out with the nearby electrons oscillating as well, and the average kinetic energy of the entire thing, the entire system changes. And instead of fluorescing the same wavelengths, uh, considering that the reflection is just the re-emission of the absorbed frequency, what happens is that the absorbed energy is dissipated within the system as heat, and then some other frequency is emitted, which is proportional. I don't know what it's proportional, but yeah, I guess there are a few laws regarding this. I did read up something here, something proportionality. This and black bodies, 1 over temperature is proportional to the wavelength. Some law regarding this, whereby you have this wavelength curves and all of that, and that's what the entire point is about. So black body is something that has total absorption, no reflection. Total absorption, no reflection, or if there is reflection, of course, no transmission as well. That's a black body, and radiates out based on its temperature, not the incident light. And eventually, based on the temperatures of the black body, you get these curves, and you try to predict the curves based on different laws. And then you have the Rayleigh-Jeans law, which says that this curve is a function of the frequency and some way, and it uses classical mechanics. It doesn't work because in the ultraviolet range it just blasts off to infinity, but it actually goes something like this. And so Planck comes in, and he's using mathematical tricks used by, I don't know, Lord Kelvin or someone, I don't know. I'll point out to the video, and he thinks that, okay, if I make the energy as something that comes in packets, so the energy is n times some energy E naught, which E naught actually is h nu, actual Planck's law. He says, okay, based on this we can explain this. And he doesn't believe that energy comes in packets. He thought that he will take the limit as h approaches 0, and he'll eventually prove that h is actually 0, and so he'll just get around the problem. But eventually he realizes that h is not exactly 0, and what he gets is something unusual, and he himself does not believe it. He does not understand what that means, and Einstein comes along, and he's like, okay, you know what, energy comes in packets, so why not make them particles? And then you have the entire photon thing, and that's how things happen. So that was that. Thank you, and yeah.